Okay, let's talk velocity versus acceleration. You hear these terms a lot, but what's the real difference?
So here's a classic physics puzzle. A car turns, holding a steady 30 miles per hour. Is it accelerating?
To solve that, we first got to nail down what velocity really means. It's not just about speed. The big secret? Velocity is a vector, and that means its direction matters a lot.
So it isn't just how fast you're going, but which way. That's the whole ballgame.
All right, now let's bring in its partner, acceleration. And it's all about change. So yeah, speeding up, slowing down, or even just turning a corner, that's all considered acceleration. And that solves our puzzle. The car is accelerating because its direction is changing. Pretty cool, right? Okay, let's get a little tricky. Can you have positive velocity but negative acceleration?
You bet. They can actually work against each other. Just look at what happens when you're slowing down.
Right, when you hit the brakes, you're moving forward, but that acceleration is yanking you backward. So, what's the best way to see all this in action? You guessed it, graphs. Let's start with a position time graph. It just tracks where something is over a period of time.
And on this graph, the slope of the line is the velocity. The steeper it is, the faster you're going.
Okay, now for a velocity time graph. This one's a bit different. It tracks speed over time. On this one, the slope gives you the acceleration. It's really that simple. And check this out. The area under the line, that tells you how far the object has moved. All right, theory's great, but let's apply this to a real test question you might actually see. So, a car is moving forward, but it's hitting the brakes. What's happening? Let's break it down. See? The velocity is positive, but the acceleration is negative. They're opposites when you slow down.
Now, be careful. Test makers love to set traps. Let's look at some common ones so you don't get caught.
Things like thinking acceleration has to be in the direction of motion. We know now that's not true. So, if you remember one thing, make it this. Acceleration is about the change in velocity, period.
Which leaves us with a final brain teaser. When a ball hits its peak, its velocity is 0, but is it still accelerating?